3-1 quadratic functions. When we're looking at quadratic functions, they're in the form of f of x is equal to ax squared plus bx plus c. You'll also see them in standard form, which we'll go over in a little bit. But these quadratic functions are polynomial functions with the degree of 2. These polynomial functions or these quadratic functions are given to you when something that is a parabola. So it's on a graph and looks like a U. The standard form of these functions is just f of x is equal to a times x minus h squared plus k, where h and k give you your vertex. Your vertex is either the highest or lowest point depending on whether or not your parabola opens up or down. If your parabola opens up, that vertex is going to be your lowest or minimum point. If that parabola opens down, that vertex is going to be your highest or your maximum point. And the only way that you can get that is by putting these equations or functions in standard form and pulling out that h value and that k value. Recognize here that that h value is the opposite of the sign that's in front of it. If we look at our first example, we are given f of x is equal to 2x squared minus 12x plus 23. We're asked to express f in standard form, then find the vertex and the x and y intercepts of f, and sketch the graph of f and find the domain and range. So you want to remember standard form, you want this in the form of f of x is equal to a times x minus h squared plus k. So that vertex is going to be the ordered pair h comma k, and your x value or your x-intercept is the ordered pair something comma 0, and then your y-intercept is 0 comma something. So looking at this and putting it in standard form, we're going to take that f of x is equal to 2x squared minus 12x plus 23. Now we're going to factor out the greatest common factor between the x terms here. So I'm going to put parentheses around the 2x squared and the 12x, and I'm going to factor out a 2 to make this 2 times x squared minus 6x plus 23. Now, with this, from here, I want to complete the square in the middle where those parentheses are, so that way I can have a perfect square trinomial, or like I said, or a binomial squared with this. So I'm going to take that b term here, which is that negative 6. I'm going to divide it by 2, and I'm going to square it. That negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to add that 9 to this binomial to make it a perfect square trinomial, as well as, since I took out that 2, I factored out that 2, I'm going to subtract 2 times whatever I'm adding into that trinomial, which is that 9. So that 2 in front stays. It also gets subtracted by the 23 that I left out of the parentheses, multiplied by whatever I'm adding to the parentheses. So from here, we're going to have f of x is equal to 2 times x squared minus 6x plus 9 plus 23 minus 2 times 9 is 18. From here, I can factor out that trinomial to give me that binomial squared, and I can also subtract the 23 and the 18. When I do this, I'm going to have f of x is equal to 2 times x squared minus, because my middle term was negative, what did I square to get that 9? The 3. Oops, this isn't x squared, it's just x minus 3 squared. And the 23 minus 18 gives us a positive 5. So from here, I'm in the form of a times x minus h squared plus k. Remember, my h and my k give me my vertex. So my vertex here, opposite of the sign in front of the 3, so instead of a negative 3, it's going to be positive 3. And then that plus 5 is my y value. So my vertex here is the ordered pair 3, 5. My a is 2. Because that 2 is positive, this parabola is going to open up. So if it's a positive a, it opens up. If it's a negative a, it opens down. So when I do this, I can plot that vertex, which is 3, 5. So I'm going to go right 3, up 5, plot the point. I know that my vertex gives me that lowest point here since I have an a value that's positive, so my parabola is going to open up here. I can look for my x and y intercepts by looking at the original function or the original equation that's given to us, that 2x squared minus 12x plus 23. I can also use that 2 times x minus 3 squared plus 5. Doesn't matter. Totally up to you. When you do your x and y intercepts, remember x is something comma 0. Y is 0 comma something. Easiest thing to do is to find that y-intercept first, because you know this parabola opens up. You're not going to have an x-intercept. So because this opens up, we are going to plug in that 0 for x. You get that y is 23. We cannot fit that on our graph. So when we graph this, we are just going to go all the way up, make this a little bit more narrow on both sides, and our parabola is going to look similar to this. Now, to find your domain and range, think about this. Your domain, what are the x values that are being covered? Well, as this parabola goes up, it continues to go out. So that's all real numbers. Use your interval notation. You just have your negative infinity to positive infinity. Your range, think about your lowest point. What's your lowest y value here? Your lowest y value is that 5, and then that parabola goes up. So what are all of the y values that are being covered by this parabola? Well, from 5, including the 5, all the way up to infinity. So putting this into interval notation, we are going from 5, including the 5, so that there'll be a bracket on the 5, up to infinity. So bracket 5, comma, infinity, close parentheses. The next part of your lesson goes over maximum and minimum values of your quadratic functions. So with these parabolas, you have a maximum and you have a minimum. That maximum and your minimum come from that vertex. The maximum is the y value from that vertex. Same thing with your minimum. It's that y value from your vertex. You know whether or not you have a maximum or a minimum based off of your a value. If your a in front of that x minus h squared is positive, so it's greater than 0, you have a minimum value, and that parabola opens upward. If that a value is a negative, it's less than 0, and you have a maximum value, and that parabola opens down. If we look at our next example, we're given the function f of x is equal to 5x squared minus 30x plus 49. We're asked to express that in standard form, to sketch it, and find the minimum value of f. So first thing we got to do is rearrange this function into standard form. So we're going to take this f of x squared, or f of x is equal to 5x squared minus 30x plus 49. I'm going to put parentheses around the 5x squared and the negative 30x and factor out the greatest common factor, which is 5x. So this is going to give us 5x times x squared minus 6x plus 49. Now, from here, my b value there is at negative 6, so I'm going to do negative 6 divided by 2 squared to get that c value. So that's going to be negative 3 squared, which is 9. When I add this 9 into that set of parentheses, I'm also going to take what I pulled out, which is a 5, not a 5x, and subtract it from the 59 times whatever I'm adding in to that set of parentheses, which is 9. So this is going to give us 5 times x squared minus 6x plus 9 plus 49 minus 5 times 9. So this is simplifying by doing 5 times, factor out that trinomial, that's x minus 3 squared, add the 49 with a negative 45, that gives us a positive 4. So we have a vertex here of negative 3, 4, an a value of 5, so a is a positive number. That means our parabola is going to open upward, and we're going to have a minimum value. That minimum value comes from that y value from that vertex, which in this case is 4. So our minimum is 4. We can plot that negative 3, or sorry, it's not negative, it's positive. Think opposite. So your vertex is 3, 4, not negative 3, 4, 3, 4. We plot that 3, 4 on our coordinate plane, and then this parabola opens up. We know that we have a y-intercept of 0, 49, which we're not going to be able to fit on this graph. So our parabola is going to be very, very narrow as it goes up. Now, you want to think about this. Is this correct? Well, look, if you ever question any of these, you got to look at your A value. If your A is positive, that parabola should be opening upward. In fact, it is. So you definitely have a minimum value here because it will be the lowest point on that parabola. If your parabola, we said, opens down, then you have that maximum point, which in this case isn't possible. If we look at our next example, however, we have f of x is equal to negative x squared plus x plus 2. We're expressing this in standard form and then sketching the graph and finding the maximum value of f. So first thing I'm going to do here, I have a negative there. I don't want the negative there. So I'm going to put parentheses around these two, factor out the negative 1. I have x squared minus x plus 2. From here, I am going to take that negative 1, divide it by 2, and square it. That gives us 1/4, or 1/2 squared. Negative 1/2 squared is 1/4. There we go. So when we go to add this in to that set of parentheses, we're going to take that negative 1 that we factored out and subtract by it times what we're plugging in or adding in to that set of parentheses. So we have negative 1 times x squared minus x plus 1/4 plus 2 minus negative 1 times 1/4 is negative 1/4. So these turn into positives. We add those. So that's going to be negative 1 times, factor it out, x minus 1/2 squared plus 2 plus the 1/4. So that's 2 and 1/4, or 8/4 plus 1/4. That's 9/4. So this is giving us f of x is equal to negative times x minus 1/2 x, or sorry, 1/2 squared plus 9/4. If you want to write this 9/4 as a mixed number, it might be easier for you to graph that ordered pair. I will do that when I give my vertex. My A is negative 1, which means my parabola is going to open down, and I have a maximum value of that y value in my vertex. So that maximum is 9/4, or 2 and 1/4. My vertex here is the ordered pair 1/2, comma 2 and 1/4. So when I graph this, the 1/2, 2 and 1/4 is going to be about here. I have a y-intercept of 2. If I want to find my x value, I can do that by plugging in, or my x-intercept, I can do that by plugging in 0 for y. I know that this will mirror on the other side, so I can just do my parabola based off of these points. And then I'm fine. So again, we look at this function, we have an a of negative 1. Because that a is negative 1, we have a maximum value that which comes from our y value from our vertex, and our parabola is going to open down. With maximum and minimum values, you can also find these values based off of a specific formula. So this formula you can use with the form of that ax squared plus bx plus c. We see also that you can find your h by taking negative b over 2 times a and k, which is equal to c minus b squared over 4 times a. For your maximum and your minimum value of your quadratic function in the form of ax squared plus bx plus c, you can take x is equal to negative b over 2 times a to find that maximum or minimum value. With these, you would have to look at your A value that you're starting with. If A is positive, then you have a minimum value. If A is negative, then you have a maximum value. So if we look at our last two examples, we're just finding the maximum and minimum values of these quadratic functions, which we can use those formulas of x is equal to negative b over 2 times a. So with example A, we are given f of x is equal to x squared plus 4x. With this, our a is 1, our b is 2, our c is 0. We don't have a c there, so it's 0. So to plug these in, we first want to look to see if we have a maximum or minimum. Our a is a positive 1, so that means that our parabola is going to open up, which also means we'll have a minimum value. So we're going to use x is equal to negative b over 2 times a. This is going to give us x is equal to negative 4 over 2 times 1, which is just x is equal to negative 4 over 2. So for our minimum value, x is equal to negative 2. For our second equation or function here, we have b, which is g of x, is equal to negative 2x squared plus 4x minus 5. So our a value is negative 2, our b value is 4, and our c is negative 5. To find our maximum or our minimum, we're going to look at a. A is negative 2, so that means our parabola is going to open down and we'll have a maximum value. To find that maximum value, we'll use x is equal to negative b over 2 times a. So plug their values in. We'll have x is equal to negative 4 over 2 times negative 2. The 2 times negative 2 is negative 4, so that's x is equal to negative 4 over negative 4. Any number over itself is 1, so our maximum value is where x is equal to 1.